first rodeo?
I said not my first rodeo.
Okay. I was concerned there.
I know, so am I. You keep inviting me back. Why do you do that? Do you want to punish me for it?
Wait. But you keep accepting.
It was.
You keep accepting.
I know. So, I have an addiction.
Addiction? Do you need a clicker? You good doing
I'm
your own
good.
thing? Okay.
You know me.
All right. So, take it away. It's all you.
All right. Well, thank you very much for having me back. First off, I have made the sacrifices to the demo god. Since we're going to do a live demo, I asked for a little bit of patience because yesterday, what actually happened was I was updating the slides. My computer shut down and it said now installing Windows 11. So today we're going to go through and talk about building better requirements and using zero trust architecture as a mechanism to explain this. For a little background, this presentation is my personal views as an IT security practitioner. Earlier or late last year, I officially got a promotion from a security engineer to a security architect. As an engineer, I was dropped in on an established project. I was told exactly here are the fields that you're going to have to go through and take. Now as an architect, I'm building out the future, building out patterns, enterprise architecture, building blocks. And as part of this, the earlier that we can go through and find a defect, find a problem, the quicker it is to go through and to fix that. Another disclaimer, I work for a very German organization. And while I love the organization that I work at, as a kid, when I used to think, I was a big fan of race cars. And when I think of cars and race cars, I'd often hear the term German engineering. I'll tell you what, the expectation now working for a German company is a little bit different than that of what I thought as a kid. And as when I got my promotion, one of the things I had to do was to attend a 40-hour class exclusively on writing better requirements, on going through and optimizing at all phases of the cycle. That being said, I'm at Micah K. Brown on Twitter. That GitHub is where I post all of the slides that I can. So we're going to start out with first, what is zero trust architecture? Now, if you haven't read this book, and you're interested in ZTA, you really should read this book. It's really good. I'm going to give you a summarization. But in terms of zero trust architecture, this is where, when I think about it, I think about going through and having a separate from the systems that are doing the authentication, centralizing that with a central authentication strategy and mechanism, and we'll go through that here in just a minute. So right here is the corporate view of what ZTA is, but to me it's about getting a new way of going through and handling various identities, whether they be machines, whether they be services, whether they be the users. ZTA is something that you cannot buy. ZTA is something that must be prevalent throughout your entire environmental stack. So when we talk about what does zero trust apply to, it applies to user identities, machine client identities, your apps and your services, your networking devices, and all interconnections therein. And with that, one thing that I often see left out is the integrity of your software is just as important as the integrity of your hardware. So, I said that I had to spend a 40-hour training on building better requirements, and I wasn't aware of free and open tools that go through and help you. And one of the best is TOGAF. So TOGAF is an open framework that'll help you go through and do better process architecture, process engineering. When you go and look at the specific URL that I put here at the bottom, it helps outline what better requirements are. Now, in working in my organization, we take a lot of times with requirements. That way, when we go through and agree to a project, it is clear from everyone that is technical to non-technical exactly what our goal is so that we can all be aiming at the same target. That's one of the biggest frictions that I run into is, especially in very large organizations, oftentimes it's hard to do the simple things at scale. So by going through and having correct requirements that are easily and understandable, we can help reduce that. So one of the first rules is the simpler the better for your requirements. You want them to be at a 7th or 8th grade reading level, just like the newspaper. Next, we need to have a common format. So in my organization, we use subject, a condition, and a target model. And we'll go over each of those. Each requirement should have one targeting model. I see a lot of requirements that and a lot of things together. And when you go through and you are asked as an IT security practitioner to show either in documentation or in evidence, whether it be from an auditor or your second line of defense, if you go through and your requirements together, it's going to make it that much harder for you to specify how you meet an individual requirement. And once again, this will become clearer in a minute. We need to unify on common terms within your organization. I'll show you that here in a minute. We need to clearly define how conditions are defined within your organization. And this is something that TOGAF will give us some guidance here. And requirements must be agreed upon on all stakeholders. Now, just because a requirement has been agreed to, there needs to be a way to amend it in case something happens, but it should be a formal process that when we amend a requirement that we also go through and we get all buy-in of all stakeholders once it is amended. And finally, the requirements should be reviewed often throughout the project to make sure that they're still valid, especially if you're in an agile development. So when it comes to the open group or TOGAF, this document right here goes through and defines what they recommend for conditions. So once again, you have a subject, a condition, and a target model. So they use the term can to imply something that could be done. May is optional to be done, where can is it's possible to do that specific thing. Shall, and it's either shall or must, depending on your organization. That means it's mandatory that you must do this, or you shall do this. Shall not means that you cannot do that. And should, and this is where, honestly, I've gotten in a lot of arguments with my second line of defense, with my auditors, my third line of defense, where they ask me, why are we not doing a should requirement? And I respond back, well, according to our organizational structure, should is optional. It's strongly suggested, but not mandatory. And let me tell you, that can go through and can cost you a lot of time. So, some actual requirements that, how should I say this, that I find exceedingly bad. Ones that are overly broad. If you are a first line, how are you going to answer security controls address different levels of protection objectives? Do you just show them, here are all of our tools? Do you say, here are all of our organizational norms, our guidelines, our work instructions? So in this case, I would go through and I'd work with the requirement owner to go through and make this a little bit more specific. The next one is when people are starting to write requirements, sometimes they try to get too fancy. And so the second one is one that I had to read 10 times. And the first 9 times that I read it, I had a different interpretation of what they were asking for. So a standardized procedural and methodological framework is established to ensure the identification, assessment, and monitoring and management of risks arising from a security control. For me, I would have broken out the identification, assessment, monitoring, and management into its own requirement. Yes, you're going to have more requirements, but it's cleaner to understand, because then the emphasis is that you're looking for security risks arising from gaps from what your policy is to what you're doing. And it's much cleaner to answer for each of those and have a single mapping to either your guidelines, your work instructions, whatever you call your organizational binding documentation, or the actual controls that are going through and implementing them. So here are some examples of requirements that I just wrote up around something that could be put in as zero trust. So all connections shall be authenticated before they are processed. That is something that is crisp. That is something that is clean. That's something that's easily understood. Authentication shall be performed by the endpoints. So here, once again, we're saying that authentication is done by the endpoints. And we could define endpoints. We could say client systems. We could define the endpoints however we wanted. PKI-based authentication should use private key infrastructure. That's a little bit controversial, I know. Some would say, no, you would want the integrity that comes from a publicly certified CA. The inverse argument to that would be if you have your own CA for your own internal certificates that you use for authentication, then you are reliant on no one for your ZTA architecture, at least when it comes to certificates. Likewise, when we come to network connections, all connections should be encrypted before they are transmitted. Once again, very clear, very crisp, very clean understanding of what the ask is. So personally, I like my requirements to be under a line long. Sometimes that's not going to be able to happen, but you want to make sure that whether you're an ITSO, whether you're an auditor, whether you are an admin, that everyone can come to the same conclusion of what the ask for when we are writing our requirements. So, let's go over a little bit of zero trust architecture. So we split things out into the data plane as well as the control plane. So on the data plane, or the things that people are going through and authenticating to, we have some sort of an enforcement agent. The enforcement agent is the one that collects all of the authenticators and sends them up to the policy engine. The policy engine will then work with the trust engine to go through and make an evaluation based on the data strategy of your organization, and the result will be either a permit, a deny, or some remediation action. How does this look in the real world? Well, this is a legacy type of authentication where the client is going through and requesting access to, in this case, a web server. The web server is going to review the authentication request, and either it is going to make the permit or deny decision, and if it accepts, it's going to go through and initiate a session. Yes. Oh, don't worry about it. We're all good here. We're friends. Now, in a ZTA world, it looks a little bit different, and this is going to look different based on what technology you're going through and implementing, so I'm making a high-level argument here. But in this case, the user is going to send an authentication request up to the control plane. The control plane is going to evaluate it based on your policy, based on what you've defined that your authentication rights are, and then if it is allowed, it's first going to go through and send a connection to the web server that say this user with this access token is going to be allowed to do whatever it's allowed to do, its authentication profile, and then the client is given that ephemeral access token so that when the client reaches out to the web server, that access is dynamically created. Now, as part of a good ZTA structure, not only do you want to make sure that you're creating that initial connection, but you're also going through and monitoring that session information as the environment changes per your policy. So let's talk about the building blocks. So at the core, we're going to start out with what people call ZTA authentication options. I prefer compatibility matrix, and that is all the factors that you can go through and you can take in when you're building out your ZTA policy. Now, what we do then is, with our organization, we work with each application as we're moving them from legacy authentication over to our new ZTA area, and we build out an individual profile that is influenced by that application's individual requirements, as well as some default requirements. So in our organization, we have a data classification, and that data classification is based on what classification of data that application stores, processes, or transmit. So we use a slightly different than what I put up here, but basically we have public, which we have very generic type of base requirements, but if we go to internal, only supposed to be used inside the organizations, there's a few more requirements. Strictly internal is even more, and confidential is even more. So once again, we'll first, when we're working with the applications to define their application authentication policy, we'll first take in the correct level, whether it's public, internal, strictly internal, or confidential authenticators, and then we'll add on any custom authentications that they need. The problem is with ZTA, you can ask a lot. And the more options you require as part of your authenticators, the more possibilities you're going to have to go through and define. And really, it can get out of hand really quick. So when we were going through and building out our control matrix, we started out with we wanted to have attributes of authentication about a user, a device, or the access/application. So then we went through and we started to build out what options might we care about. For the user, are they an employee? Are they an executive? Maybe a contractor, maybe a partner, maybe an admin. That might always influence what type of access you give a person when they authenticate to that application. You might care about standard errors. If you care about it, build it into your authentication matrix. If you don't, delete it. This is just something that's going to help you, and I'll show you how we actually build this out in just a little bit. User last geolocation. Now, this isn't perfect, so I very rarely go through and recommend this. Sometimes it's easier, especially if you own the IP space. You could define certain locations as, in the office, or a partner if you're using a direct connected connection, maybe a VPN tunnel, maybe something else, customer, non-trusted. Another one that's that we've had very interesting use cases is if the user hasn't been seen in a specific amount of time. So in that case, I would say that would prompt for maybe a remediation action, like check with or have the user approve themselves with two-factor authentication. So that's the main use case that I've seen with that one. When we moved to device, once again, we wanted to keep the options as limited as we could. So device type, obvious one. Is it a standard corporate image? Is it a non-standard corporate image? Is it a corporate phone or tablet? Because those have slightly different attack surfaces. Is it a partner device, a BYOD? Or is it a non-trusted device, meaning that you don't know anything about this? Has the device been seen in the last 30 days? Once again, this has been utilized most often to ask the user to go through and to provide a two-factor authentication before they move on. You might care about the device OS. Is it Windows, Linux, Mac, iOS, iPad OS, Android OS, iFridge OS, which is coming out at the next WCC. You might query about the device patch level. So when you're doing some of these more advanced, you might need to have that agent on the end device, or you might not be able to do things like this or device AV on. It depends on, once again, what solutions you're using. But if a device is not up to date, or it doesn't have AV or has old AV signatures, you might want to put that on a remediation network where they could download that, try to re-authenticate, and then once they pass, be led on to the appropriate network. Now we want to talk about the application or the access size. So one of the big ones that I might care about is the request type. Is this someone trying to interactively log on with that application, with that resource? Is it a read-only display? Is it an API? Is it a web? Is it a file or data transfer? Next, we have some applications, because one of the applications that we use, it has scheduled downtime every night, so it can go through and do mainframe things because it still runs mainframes, because in this year we still have mainframes running in our organizations. I really don't like geolocation when it comes to the applications, but sometimes this is needed. So if the system that they are trying to go through and access is in a certain location of the world where the user is not allowed to access that data from, you might have to have this. I can't go into any further detail into that here, but there are some interesting use cases that we've stumbled along being a global organization. One of the ones that I really like is the data classification. So once again, what type of data is stored, processed, and transmitted. We have some default rules built around that, absolutely. We found that we thought we were going to use business criticality as measured in uptime, but we ended up not using that pretty much at all. So that's one that you can probably go through and not leverage. And one of the bigger ones that I care about is the authentication access type, because there are some of these types that I inherently trust more than others. I personally go through and I trust a hardware MFA backed up with a password a whole lot more than I trust an app MFA with authentication, which I trust a whole lot more than just username and password. So once again, all of these are types of options that you need to determine. And once again, you might not care about biometrics, so delete it from your access profile. You might not care about a near range like an NFC token, so remove that from your authentication profile. You're going to be saving yourself a whole lot of headaches. I'm not sure why. Oh, I hit the. So when I went through and did a total calculation just based on that authentication profile, this is how many unique use cases I'm going to have to go through and deal with. How long is that going to take you? Clearly, this is not the way, right? I was being a big dum-dum. So, how can we get this number down? Requirements engineering, baby! Let's go on an adventure! So this is where we sit down with the application owner that we're looking to migrate. We say, okay, here's, based on the data that you store, process, and transmit, this is the default set of rules. What do you care about from our actual capabilities matrix, which is all the options that we allow authentication by? And the key is, less is more. You want to make it as simple for yourself in your policy setup, because obviously we're not going to write over 603 million rules. That'd be horrible.
Why not?
So,
your user authentication thing.
Yeah.
That you didn't include a line entry, or excuse me, I guess it was a device for work outside the office.
So once again, all of those are options, and you could, if you definitely care about that, you could factor that in, absolutely.
And just multiply your numbers.
It just adds to the number. My liver's going to hate me after this project. It already does. Who am I kidding?
Oh, yeah.
So I went through and I added just these 3 simple rules. I'm not going to read them to you. In fact, they don't matter because it's completely fictitious. I made this all up for this talk so I could talk about it. But when I did that, look, we're now down to just over 37 million rules. We're making progress, right?
Can we also add a fourth rule for like the first time people attempt to sign on?
Yes! Absolutely. That's the beautiful thing is when you're writing these requirements, you get to write these requirements and get all of the stakeholders, and by the way, the proper spelling of stakeholders as STEAK-holders.
That will definitely get annoying.
Then,
Are they taking you off too?
absolutely, Matt's buying. Not really. But then we add these 4 additional rules. Now we've dropped to 3.5 million. There's power in these rules. So as we write these 3 more, we're now down to 45,000. Eventually, we settled that this application target is going to support everything that's not crossed out here. So we're going to care about users. We're going to care about type. We're not going to care about non-trusted. We're going to care about the request type and the authentication type. And in this case, the only thing that this fictitious application accepts is passwords, token, biometrics, password and token, password and biometrics, or single sign-on. And when we go through and did that, we got it down to only 1,000 unique, undefined combinations. And that's something that we can go through and start to work with, right? Once we get things down to that scale. So how did I go through and do all of those calculations? I use Access. You could do it in Excel. You could do it in any type of database. But I quite frankly, and I'll show you the type of Access database that I use as I'm helping guide so that I know based on our requirements and I can see any holes that we do not yet have. And so all I do is I create a table for each of these columns and I populate it with each of these options. Then I write a report that just ands them together. And that's where we can really go through and we can start to see some real power when it comes to going through and being able to identify things where we can write rules to make things make sense or where there's situations that just won't happen. So right here's an example of the query that I filled out. It's pretty simple. I just bring in each of those actual tables and I just and them together. And I'll show you this in real time. Don't worry about it. You'll get a report such as this. And you can start to see interesting combinations. Is your admin going to be on BOD and want an interactive session with one of your say web servers? Probably not. It would be horrible to try to, go through and use the command line if you're using Linux on a cell phone. Would you ever expect a customer to have a corporate device?
No.
So you could go through and write a simple requirement that says that customers will not have a corporate laptop or corporate device. Or customers will not have BYOD devices. That if they try to log on from those types of devices, deny them.
Shut it down.
Exactly. I see you're a John Tapper fan.
Yes.
If only John Trellick's were here. So, I know I've gone a little bit faster than I was expecting, but the main point of this is when you go through and are starting to develop a zero trust architecture, it's going to be hard. The more authentication options that you go through and define, the harder it is for you to write a robust rule set that'll go through and that will A, be sustainable, B, be manageable, and that you can actually go through and maintain and troubleshoot. ZTA is not something you can buy. It's actually one of the harder projects that I've ever been on, and truth be told, we're only in our first beginnings of actually going to there. I see a lot of benefits in ZTA, and the truth is, how ZTA is implemented, how it functions, how it works is going to differ from organization to organization to organization. To me, it's more about discipline. It's about doing the simple at scale. And you don't have to use my hack of an Access database, but you need to find a way so that based on what your authenticator profiles, based on what your default rules for each data classification or each system classification, however you write your default rules, that you can define where you need to augment and where you need to help guide the application owner to build their own authentication profile, because they're going to be the ones that have to go through and to implement it. And the one way that you can view this is that the application owners are responsible for their app's authentication profile. Whoever is running the ZTA architecture tool, hands on the keyboard response, is responsible for going through and implementing that application's authentication profile. And just like user entitlement, you probably should have regular review of your ZTA authentication profile for each application, be that yearly, bi-yearly. You get to define that, but they should be regularly reviewed. So assume no access unless mutual trust has been established. That's just one of the general rules of ZTA. It is a way of being not an end destination. You're constantly going to go in, modifying, updating, tweaking, troubleshooting, and it requires a lot of interoperability that you're going to have to go through, and often you're going to find that certain systems networking, mainframes. You're going to have to find a workaround, or you're going to have to go through and replace them as you transform your applications from a non-ZTA to a ZTA architecture. With that being said, I'll go through and I'll bring up the Access database. So as you see, I implemented a bunch of tables, and when we look into the authentication types, here we're just looking for password, certificates, token codes, biometrics, password and token, password and biometrics, and single sign-on. We could add more if we wanted to. I don't want to. Less is more when it comes to authenticators. Here is the device types. Right here is the actual view of the query that I wrote to do the logical and if I just go through and run it, here is the results. And, just scrolling through here, if we go through and come down, we could take a look at would the customer ever have a partner device? Probably not, right? So we could go through and we could write a simple that customers can only log in with unknown device types, or must only log in with unknown device types. That being said, any questions?
You happen to have a slide that showed going to a third party for ZTA trust authorization. I didn't see any back channel from the target web server back to that. It's just a one-way arrow.
So let me bring that up. Are you talking this?
Yeah, there's only one down the right side.
Oh, I got you. So right here, what I'm showing is that the act, and you're absolutely correct. I should have had a second arrow downward. I was just showing that the control plane sends the user its ephemeral access token, and then the fifth step is the client gives that to the web server, and that's when the session is established. So I definitely should have put a second line here.
Well, I was thinking about between the upper cloud and the web server.
Oh, absolutely. So as part of this, I try not to make this slide too busy. And so this is the control plane. It's not necessarily a third-party cloud. This is actually the combination of your data strategy, your policy engine, and your trust engine.
Okay, so it's just conceptual, it's not actual traffic.
Correct. I'm just showing that what happens is the user system first makes an access request to the control plane. The control plane then is going to evaluate should that actually be allowed to happen. The next step, if it's approved, the actual access token is first sent to the web server, and the web server automatically, at that very moment, it provisions the access based on the policy.
But there's no machine in the middle getting in the way.
So there can be one dimension. Yeah, there's a ton of networking. There's whatever your control plane looks like, which is you can have a distributed policy. In fact, I suggest you have distributed sets of both policy engines, trust engines, data strategy spread out over your network. So if you have a single point of failure, the system can remain up, or else you're going to be out of luck. So this was more just showing the steps that happen. So user requests access to a resource from the control plane. The control plane evaluates it. If it's allowed, the control plane will then reach out to the web server in this case and say, here's an access token and these are the rights that it gets. The actual web server will then dynamically provision that access. At the same time, well, near same time, the control plane will come back to the user, say, you're allowed access, here's your access token. And then the user will use the access token to authenticate to the web server, in which hopefully that access has been provisioned correctly and they're allowed in.
Now the web server will only use that token that one time. From that point on, that token's no longer good, so somebody else can't grab it and look like they're...
Ideally, yes, but you'd have to go through and you'd have to set that up as part of the access policy. So you could say that a specific token is only good for 2 hours or 8 hours or 4 hours, whatever time frame you want to force a re-authentication.
Or even from a particular IP address, I presume.
Oh, absolutely. That's where you might want to get a little bit more fancy when you create your capabilities matrix, but as we saw, the more options that you have, the larger your work is going to be. So in terms of my advice to you, less is more. If you take a look at what we finally arrived on just for this simple, we were only looking at 4 types. And that is pretty good in terms of going from traditional to your start of ZTA is 4. You might go up to 5, 6, but once again, the more options you have, the harder it's going to be for you to write a robust, supportable, defendable rule set.
I realized this talk was more like a top-down from more of like a GRC management view. Mm-hmm. From an implementation standpoint in general, and from, say, an application or application development standpoint in particular, what are the kinds of things that you would be looking for from your app developers in terms of taking like a legacy line of business app and then plugging it into something like this?
So if you look at some place like Google, they coded their entire own set. Other applications will go through and acquire, say, for servers and web servers, a ZTA type agent that'll then plug into the control plane to facilitate that. So the question would be, first, are you going to roll your own? Or are you going to implement a vendor? Now, it's probably going to be a lot easier for most organizations to leverage an agent on both the authenticator and the authenticated to the resources that they're trying to, and then you use that vendor to go through. Now, if you choose the vendor, then you have to worry about compatibility, as I alluded to. So there might be some legacy systems like mainframes, or maybe you're a certain hospital and you have machines that are still being controlled by Windows XP. Heck, I used to work in a factory during college, and some of the machines that they were still running, that they still are running, are even pre-Windows NT. But you know what? To operate that CNC machine, it would be thousands and thousands of dollars for them to replace that machine, so it's not...
There might not be authentication agents on that. So this is going to get you in a green field like Beyond Core. You can do this. The masks are solid. You're going to have fringe cases.
So
you can leave those out of the main policy.
Yep.
And they become the exceptions, and there's someone else's problem.
And there's going to be growing pains, absolutely. And you're definitely right. This was meant more from a strategy down, and I was more shaping this to show how writing good requirements makes things so much easier when you go everywhere from agreeing to what we're going to do all the way through implementation and maintenance.
I like interpreting that to the fact, did we follow our own policies?
Absolutely. And not only that, are your policies defensible, especially to third parties?
And that leads right into my next question, which is zero trust is a great example of something that can be really tricky to implement, especially if you're just starting out. What are some other good use cases where this type of approach would be really helpful?
So in my mind, zero trust, as you said, is very, very tricky. I think there are a whole lot of great things to go through and to come out of a zero trust strategy. By going through a zero trust strategy, you're getting beyond, this application, we only have TCP port 80, port 443, and 22 open. We're creating authentication that is much more resilient and is proportional to the asset's value. Oftentimes in IT security, in the past, how many of us had paid $10,000 for a firewall and it ends up protecting, a system that might have only $10,000, or we pay $100,000 for a firewall and it's protecting, 10,000's worth of data. With Zero Trust, it allows us the flexibility and the scalability to build out true risk-based authentication. Does that help?
No, but I'll pester you later.
Oh, any time. But this is going hand in hand with a global network segmentation strategy. So it's driving a lot of the fundamentals. As I've spoken with you before, one of the hardest things to do at an enterprise at size as you grow is the simple things at scale. I mean, how many of us have a lot of trust in our CMDB? And think about all the tools that we have to help.
That was actually where where my mind was going, was just the whole idea of asset management in general, because it's another one of those things that you somehow have got to distill the right pieces of information down to something that you.
Oh, absolutely. So as we were going through and we're building out the application profile, authentication profile, that's going through and making sure that every application within that specific, or every device or entity within that application is known and their access profile is defined.
Okay. Oh, one more.
Your slides aren't up on your GitHub repo yet, are they?
Well, I had the great Windows 11ing last night,
yes.
And then I was doing some updates here, so I took the old version down, and I'm going to put the new version up.
And share them with us.
And I'll share them with you, of course. Thanks, Windows 11.
Yeah.
Everything they say, everything they do.
Yeah. All right, thank you.
Thank you.
All right, so